Focus for today is Boyle's law. And just to make things a little bit easier, I went ahead and I included for you here the actual formula for Boyle's law, which is P1V1 equals P2V2. And I made a reminder for you as well with what all of your pressure unit conversions are. So I brought back that 1 atm equals 760 millimeters mercury, so on and so forth. And you can see those written in blue. As a reminder, if it says P1 or V1, that means that was the initial pressure or the initial volume. If it says P2 or V2, that means the final pressure or the final volume. So let's look at question A. Question A says a 1.04 liter is an example of a volume unit, sample of gas at 759 millimeters mercury pressure is expanded until its volume is 2.24 liters. What will the pressure in the expanded gas sample at constant temperature? So this right here, sorry guys, at constant temperature for you is not important. This is not going to change how you answer a question. And so the first thing you want to do is you want to look at your question and you want to identify what variables have they given you. So they've given you a 1.04 liter. You know that this right here is volume because volume is measured in liters, milliliters. Liters right here is your unit. A 1.04 liter sample of gas at 759 millimeters mercury pressure. They not only give you the units of pressure, but then they also tell you that it's pressure. So this is the volume and this is the pressure. That gas is then expanded, so it's made bigger, until its volume is 2.24 liters. So now they've given you a whole new volume. So I'm going to underline that in a different color just to make things a little bit easier for us. So this right here is another volume. Then they're asking you what will the pressure in the expanded gas sample be? So they're looking for the new pressure of the expanded gas. What's really important for you is that you keep your P1 and V1 together and you keep your P2 and V2 together. So here's what I mean by that. This volume right here, the 1.04 liter sample of gas, that was at 759 millimeters mercury pressure. So this is your V1, and this right here is your P1. The reason why I know that this is the 1 and not the V2 P2 is because they're telling you in the question that that gas was then expanded. So that's now going to, whatever the expanded gas is, the new volume, the new pressure, that's going to have to be your P2 and your V2 because that's your after. The 1 is always the before, the 2 is always the after. So I want to make sure that I keep whatever my before is, in this case 1.04 liters, with my before 759 millimeters mercury pressure. So my volume before, my V1, and my pressure before is my P1. Then they also told me that now that gas was expanded until its volume is 2.24 liters. So this right here is my V2. They're asking for what will the pressure be in the expanded gas sample, so the pressure of the V2. So I'm now going to search for the P2 pressure. If I now go back to my formula, which is always P1V1 equals P2V2, I'm going to practice isolating the variables in the video notes just because that's something that we would be doing in class anyways. If you're comfortable with this step, then you can just fast forward until I get to what P2 equals. So I'm searching for P2, which means that now I need to get rid of V2. P2 and V2 are multiplied with each other. And so the opposite of multiplication is division, which means that I'm going to now divide both sides by V2. Once I do that, I now got rid of V2 over on this side of the equation, which means that I'm left with P2 equals P1 times V1 over V2. Now that I have my formula set up, I can now just plug in my variables. So my P1 from my question is 759 millimeters mercury. That's my P1. I'm going to multiply that by the V1, which was 1.04 liters. Then I need to divide all of this by my after volume, my final volume. And this time around, it's 2.24 liters. I'm just putting things in parentheses to make sure that you can see what each variable was representing and to make it a little bit neater for you. Now all I need to do is I need to multiply my numerator and divide that by my denominator. So I'm going to take this a bit of a longer route and show you that if I multiplied 759 by 1.04, I'm going to be left with 789.36. 2.24, I'm not doing anything with that in the denominator, so I'm just going to leave that as 2.24. Then, once I go to my calculator, I'm now going to take 789.36 and divide that by 2.24. When I plug that into my calculator, I get 352.3928.571. Now let me go back and figure out what unit I have. Hopefully you can recognize that the unit of pressure is going to have to be one of the possible units of pressure, but it has to come from whatever was left over in your formula. So we've done this before. Liters in the numerator cancels out with liters in the denominator. My only unit remaining is millimeters of mercury. Millimeters of mercury is a unit of pressure. So when I come back here, I know that my unit has to be millimeters of mercury. Remember, it's always whatever unit is left remaining in your formula. The last thing I need to do is I need to deal with sig figs. This was 3 sig figs, 3 sig figs, and 3 sig figs. All of those were my data. So each one of my data had 3 sig figs, which means that my final answer is just going to be 352 millimeters of mercury.